Hi everyone, it's Tara. Welcome to my channel. Of course, I am here to do another TryHackMe room walkthrough on the Intro to DevSecOps path. This room walkthrough is the Secure SDLC room, or the Secure Software Development Lifecycle room. So this follows the Software Development Lifecycle room, which I think was maybe like the last video I posted, one of the last ones. And this is the SSDLC room. And I actually just got done playing it, and then I came to film this intro. So this room is definitely a lot of reading. There is a fun little like hands-on game at the end. So if you want to hear me drop the F-bomb, feel free to just fast forward to that part. But there are some really interesting topics like secure coding and secure development, different security assessment frameworks, etc. This room also wraps up the secure software development module of the Intro to DevSecOps learning path. So this room kind of wraps up some of the concepts that we talked about in the other two rooms and brings more of that security lens into things. With all that being said, enjoy this little walkthrough of the Secure Software Development Lifecycle room in TryHackMe. All right, SSDLC, and description says this room focuses on the Secure Software Development Lifecycle, or S-SDLC. So we learned about SDLC in the last room, and now we learned about Secure SDLC, its processes, and its methodologies. And let's see if this is a free room as well. So, yep, this is a free room on TryHackMe, so you can play along even if you do not have a paid for subscription. So I'll make sure and link below if you want to play the room. And of course, we'll start with task one. So task one is our introduction. It says this room focuses on the secure software development lifecycle, SSDLC, its processes, and its methodologies. In the learning objectives, we're going to understand what the SSDLC is and why it's important, learn about the processes of SSDLC, and understand the secure SDLC methodologies. And let's see what the little definition says. So this says SSDLC is an extension of DevOps practices focused on building secure products. So that sounds good. And who doesn't want a secure product? We just need to hit completed to say that we read the introduction. And look at me go. I'm up to 23 days in my streak, so I feel like that's pretty good. We'll close task one. I like to keep it nice and tidy. And here is task two. What is SSDLC? And it looks like we've got 9 tasks in this room. I imagine this will kind of be our last introduction room with a lot of reading, and then the next room after this I think will be pretty hands-on. So we have Secure Software Development Lifecycle, SSDLC. During SDLC, security testing was introduced very late in the lifecycle. Bugs, flaws, and other vulnerabilities were identified late, making them far more expensive and time-consuming to fix. In most cases, security testing was not considered during the testing phase, so end users reported bugs after deployment. Secure SDLC models aim to introduce security at every stage of the SDLC, so we don't want to wait until the end anymore. And why is Secure SDLC important? A study conducted by Systems and Sciences Institute at IBM discovered that it costs 6 times more to fix a bug found during implementation than one identified as early as during the design phase. Wow, that's pretty crazy. 6 times more. It also reported that it costs 15 times more if flaws are identified during testing and up to 100 times more costly if identified during the maintenance and operation phase. See the figure below. Wow. So I was just impressed a minute ago when it said 6 times more costly, but they think, wow, 15 times more costly if you catch it during testing and 100 times if it's after the product is already released. That's pretty crazy. Apart from faster development and reduction of costs, integrating security across the SDLC helps discover and reduce vulnerabilities early, reducing business risk massively. Examples of introducing security at all stages are architecture analysis during design, code review, and scanners during the development stage. So that scanners especially would be like example of DevSecOps, and conducting security assessments, e.g. penetration tests, before deploying the software. For example, in waterfall models, this sort of testing was carried out at the end of the life cycle, right before production. In more agile processes, we can implement a security by design approach. If the pen test results in errors like an SQL injection vulnerability in a waterfall scenario, mitigating these bugs would entail doing another cycle to fix the bug. It would require redesigning, applying the changes, and retesting to check it has been remediated. In a more agile approach, discussions on whether to prevent flaws like this such as deciding on parameterization during the planning phase, can avoid having to roll back changes, and it only costs a planning discussion. Dare I say it, but I think the point there was shifting left. Like, the earlier that we are doing our security testing and discovering flaws, the better. And here's a summary. Security is a constant concern, improving software quality and security constantly. Okay, I'm not sure that's a sentence. Security is a constant concern, improving software quality and security constantly. Oh, so I guess this part, just we want to be always worried about quality and security constantly, not just doing quality assurance at the end of the process. And then boosting security education and awareness. All stakeholders know each phase's security recommendations and requirements. Flaws are detected early before deployment, so left, reducing the risk of getting hacked or disrupted. And costs are reduced and speed increases thanks to the early detection and resolution of vulnerabilities. Business risk, brand reputation damage, and fines that could lead to economic disaster for a company are prevented. Seems like maybe this is a summary of what to expect when we are actually operating in the SSDLC model. These are the good things that will come of it. So, how much more does it cost to identify vulnerabilities during the test phase? I think that was 15, right? All right, awesome. And with that, we are already on to task 3. Task 3 is called implementing SSDLC. Oh, we got our Star Wars analogies back in. This should be good. Now I'm getting like really educated in the lore as just a side effect of this learning path. And here we go. Implementing SSDLC. As the intro to DevSecOps room shows, secure SDLC involves instilling security processes at all lifecycle phases, from security testing tools to writing security requirements alongside functional requirements. And understanding security posture, like with every new process, understanding your gaps and your state is critical for successfully introducing a new tool, solution, or change. So you have to know how things are, the state of things, what's actually going on to be successful in introducing change. You have to have a good lay of the land. To help grasp what your security posture is, you can start by doing the following. Perform a gap analysis to determine what activities and policies exist in your organization and how effective they are. For example, ensuring policies are in place, what the team does with security procedures, how the team executes those policies. Okay, so what the team does, that means policies that are in place, and how the team executes those policies is the procedures, okay? Create software security initiatives, SSI, by establishing realistic and achievable goals with defined metrics for success. For example, this could be a secure coding standard for your organization, playbooks for handling data, and pretty much I would think like most big organizations do have like data handling policies. I know any big place I've ever worked has had a strict data handling policy. And then et cetera. Oh, so just other things. And so the examples were secure coding standard, data handling playbooks and policies, and then, other such things are tracked using project management tools. Formalize processes for security activities within your SSI. After starting a program or standard, it is essential to spend an operational period helping engineers get familiarized with it and gather feedback before strictly enforcing it. So you want to have an onboarding period. When performing a gap analysis, every policy should have defined procedures to make them more effective. For your policy to be effective, you want to really have defined procedures that take the guesswork out of it and make it easy to use, and you want to upskill people on those procedures. And then invest in security. Speaking of upskilling, invest in security training for engineers as well as appropriate tools. Ensure people are aware of new processes and the tools that will come with them to operationalize them. Just so you guys know, if you notice a cut there, that's because I tried to say operationalize like 7 times. It was really sad, but I finally said it. And invest in training early, ideally before establishing or onboarding the tool. So you want to do the training as part of your change process to put your new tool or your new policy into place. And then we have SSDLC processes. After understanding your security posture, now is the time to prioritize and instill security in your SDLC. Generally speaking, a secure SDLC involves integrating processes like security testing and other activities into an existing development process. Examples include writing security requirements right alongside your functional requirements for your new product or new application, and performing an architecture risk analysis during the design phase of the SDLC. The processes are the following. So in that other room, we saw phases of the software development lifecycle. Now we're seeing phases of the secure software development lifecycle. And I believe these words that you see in the parentheses here, that's what was the phase in the software development lifecycle. And on top of the SDLC phase in the parentheses, now we also have the component we would implement if we're following secure SDLC. All right, so during planning phase, we would have the risk assessment phase. And then during the defining requirements phase, we would have the risk assessments phase as well. So that's kind of what I think where they were talking about, like defining functional requirements for your application or whatever. You would also be defining your security requirements here as well. So security requirements becomes part of the requirements phase. And let's see, in the design and prototyping phase, we want to add in threat modeling. In the software development phase, that's where we want to add in our code scanning and our review, like automated mechanisms that are checking the code as commits are being made to the code base. Same with testing, we would have code scanning and review. And actually like some of what they were saying in those earlier paragraphs, I guess they were arguing you could even put like some sort of penetration testing here if you want to, beyond just automated scanning and automated threat emulation or whatever. And then let's see, deployment, that's where we would have a secure configuration phase. Then in the operation and maintenance phase, that's where we would have security assessments. That's where you would have mechanisms like pen testing and other security assessments as well. All right, but anyway, I'm just kind of like talking out the side of my mouth, and they're going to actually describe what they mean by this. So we have risk assessment, so that was here and here. During the early stages of SDLC, it is essential to identify security considerations that promote a security by design approach when functional requirements are gathered in the planning and requirement stages. For example, if a user requests a blog entry from a site, the user should not be able to edit the blog or remove unnecessary input fields. Seems like a user can request a blog entry from the site would be the functional requirement. And then along with that functional requirement of what the user can do, here's the security implication or the security thing to think about is how do we make sure that the user only has authorization to read the blog post if that's what they're supposed to be doing and not edit the blog post or do things they shouldn't be doing. And threat modeling is the process of identifying potential threats when there is a lack of appropriate safeguards. It is very effective when following a risk assessment and during the design stage of the SDLC, as threat modeling focuses on what should not happen. In contrast, design requirements state how the software will behave and interact. For example, ensure there is verification when a user requests account information. It seems like design requirements state what we want the software to do and what we want to happen. And then threat modeling, we're thinking about all the things that could go wrong from a security perspective so we can start designing to avoid those things. Code scanning and review. Code reviews can be either manual or automated. Code scanning or automated code reviews can leverage static and dynamic security testing technologies. Those are crucial in development stages as code is being written. Lastly, security assessments like penetration testing and vulnerability assessments are a form of automated testing that can identify critical paths of an application that may lead to exploitation of a vulnerability. However, these are hypothetical as the assessment doesn't carry simulations of these attacks. Pen testing, I think that's vulnerability assessment they're describing. And then pen testing, on the other hand, identifies these flaws and attempts to exploit them like a real attacker would to demonstrate the validity of the vulnerability. Pen tests and vulnerability assessments are carried out during the operations and maintenance phase of the SDLC after a prototype of the application. There are methodologies to apply the processes in Task 5 that will help you navigate and guide you when introducing risk assessment, threat modeling, scanning and testing, and operational assurance. The following tasks will cover these processes in more detail. So, what should we understand before implementing secure SDLC processes? So I was going to say security state here, but I think maybe the answer is security posture, which is kind of like similar. Okay, yep. So we want to understand what's our current security posture, what's current status of things, lay of the land before we start implementing our new SSDLC processes. During which stages should you perform a risk assessment? Well, there was a few different, so requirements gathering, planning, and design. Let's see. Let's scroll back up. All right, so planning and define requirements. So I'm going to say maybe planning and requirements. Okay, that was correct. And what should be carried out during the design phase? That would be threat modeling. Hopefully, how do you spell modeling? Not like that. Okay, awesome. Okay, so that was the questions for task 3. And then task 4 is going to be dialing in on risk assessment. Risk refers to the likelihood of a threat being exploited, negatively impacting a resource or the target it affects. For example, vulnerabilities being exploited after a new version of the software is published, design flaws, and poorly reviewed code can increase the risk of the scenario. So risk assessment is trying to determine what are the risks here, and then like how likely are those risks? What would the impact be if that risk were to come to fruition and become a reality, and how can we mitigate the risk? And I'm sure I'm already just jumping ahead of whatever is probably about to be written here. So risk management is an important pillar to integrate into the SDLC to mitigate risk in a product or service. Risk assessment is used to determine the level of the potential threat. Risk identified in the risk assessment process can be reduced or eliminated by applying appropriate controls during the risk mitigation process. Usually, a risk assessment is followed by threat modeling, which will be explained further in the next section. Section 5 is about threat modeling. And this is about performing a risk assessment. The first step in the risk assessment process is to assume the software will be attacked and consider the factors that motivate the threat actor. List out the factors such as data value of the program, the security level of companies who provide resources that the code depends on, the clients purchasing the software, how big is the software distributed, is it single distribution, distributed to a small work group, or released worldwide? And based on these factors, write down the acceptable level of risk. For instance, a data loss may cause the company to lose millions, especially if they require to pay fines nowadays with regulation like GDPR. But eliminating all potential security bugs in the code may cost $40,000. This is so specific. The company and some other stakeholder groups have to decide whether it is worth it. Is it worth $40,000 to fix our bugs? From a brand reputation perspective, if the attack causes damage to the company's image, it costs the company more in the long run than fixing the code. Yep, makes sense. The next step is risk evaluation. Include factors like the worst case scenario. If the attacker has successfully attacked the software, what's the very worst case scenario? If the attacker really got to the most valuable thing we have, what would that mean? You can demonstrate the worst case scenario to executives and senior engineers by simulating a ransomware attack. Oh, that's true. I was kind of thinking like exfiltration, but also just being taken offline is probably part of the worst case scenario. Determine the value of data to be stolen, valuable data such as the user's identity, credentials to gain control of endpoints on the network, and data or assets that pose a lower risk. Right, so part of risk evaluation isn't just what's high risk, but also it's helpful to know what's low risk. You basically want to know, especially for data, what's the risk level of everything, what's the privacy level of everything. Another factor to consider is the difficulty of mounting a successful attack. In other words, how complex would the attack need to be? For example, if an attacker can gain access to the company's tool for giving feedback to colleagues or running retrospective meetings, it would have a lower impact than accessing a production environment's monitoring and alert system. Well, if that happens, then I hope the attacker gives me a good peer review in the feedback system. And the high level of risk, I think, meaning for if they were to access the production environment and the monitoring and alerts there, the high level of risk will not be acceptable and it is best to mitigate it. For example, a vulnerability can be exploited by anyone running pre-written attack scripts or using botnets to spread the script to compromise computers and networks. Users affected are a vital factor in doing your risk assessment and determining what the worst case scenario is, how it would affect your users. And then number 3, some attacks only affect 1 or 2 users, but the denial of service attack will affect thousands of users when a server is attacked. But if you were to be the victim of a denial of service attack and your application is taken offline, that's going to have a really wide impact. Moreover, thousands of computers may be infected by the spread of worms. The last factor, that's adding to this kind of like doomsday scenario here. Your application's offline and your hardware assets here, your computers, are getting infected as well. The last factor is the accessibility of the target. Determine whether the target accepts requests across a network or only local access. That will help you evaluate risk if you know how accessible your target is, especially via the public internet. And then you also want to establish whether authentication would be needed to establish a connection or if anybody would be able to send requests to the target. It has more impact if an attacker accesses a production environment versus a sandbox environment used in local playgrounds for people to do labs or tutorials. So obviously, yeah, that would be part of your risk assessment. You have different environments and the different environments would have different levels of risk. So they're using the example of like a sandbox environment similar to TryHackMe. But the other obvious example would be your production environment versus your staging environment versus your testing environment in your DevOps flow. And then types of risk assessments. There are several types of risk assessments best suited for different scenarios. Below are the different types. So we have qualitative risk assessment. This is the most common type of risk assessment that you will find in companies, hopefully. In a qualitative risk assessment, the goal is to assess and classify risk into thresholds like low, medium, and high. It systemically examines what can cause harm and what decisions should be made to define or improve adequate control measures. Like all types of risk assessments, each level has a priority where high has the most urgency. Even though qualitative risk assessments don't use numbers, a typical formula to evaluate qualitative risk looks like this. Risk equals severity times likelihood, with severity meaning the impact of the consequence and the likelihood being the probability of it happening. And it's up to the risk assessor to judge these circumstances. I've been in several professional environments where we have done different types of codified risk assessments as part of processes. And I would say that's pretty similar to what I, especially like in tech, working in consulting, I remember we used to do something pretty similar to that on our engagements, but also prior to that in non-tech work environments, I have always kind of seen more like the qualitative risk assessment. And then you also have quantitative risk assessment. The quantitative risk assessment is used to measure risk with numerical values. So instead of low, medium, and high, we have numbers that represent those bands. And when carrying out quantitative risk analysis, we can use tools to determine severity and likelihood, or we can use custom series of calculations based on our own internal processes. So, for example, suppose there are services with assigned business criticality levels. In that case, you can say that if a bug affects a business critical service, for example, an authentication service, payment infrastructure for your production application, etc. So those highly critical services, in this example, we would assign 5 points. This highlights why it's vital to understand a security posture and its processes. Measuring risk and priority with an endemic equation to a company's services will have great results. Okay, so measuring risk and priority, understanding what's normal specific to your environment and your services and what's expected there. And then an example of a quantitative risk assessment matrix can be seen below. And look how beautiful it is. I love the color scheme. Risk assessments are better performed at the beginning of the SDLC during the planning and requirements phase. For example, customer data gets exfiltrated by an attack would be a risk. Once the system is developed, you can perform quantitative risk analysis. For example, one customer could sue us for $20,000 if their data were to get leaked in this hypothetical exfiltration attack. And we have 100 customers. However, the annual rate of occurrence, ARO, is only 0.001. Hence, our annual loss expectancy is $20,000 times 100 times 0.001, which equals $2,000. Meaning as long as our compensating security control is less than $2,000, we are not overspending on security. All right, and then over here on our example risk matrix, we have likelihood here and we have severity here. So we're seeing that the highest severity and the highest likely whatever risks get the highest score. And look at the severity here. Insignificant, minor, moderate, major, death. So certain death is a full 25. Remember that. And what is the formula to assign a qualitative risk level? So that was, if we get them in the right order, severity times, oh, maybe it's a X, times likelihood. Oh my God, I already know I spelled that wrong. All right, let's try this. Maybe I got it right. Okay. All right, awesome. And which type of risk assessment assigns numerical values to determine risk? All right, so I would have said quantitative risk. Oh, so I got this. So I'm going to change this to quantitative risk, and then I think the third word is assessment. Oops. All right, let's see if I got it. Okay, awesome. So that is task 4. And now we'll move on to task 5, which is going to be about threat modeling. All right, task 5. Now it's getting juicy. We're going to talk about threat modeling. Threat modeling is best integrated into the design phase of an SDLC before any code is written. So I think even if you don't buy into SDLC phases that strictly, the before any code is written part is probably the important part here. And threat modeling is a structured process of identifying potential security threats and prioritizing techniques to mitigate attacks so that data or assets that have been classified as valuable or of higher risk during the risk assessment we just talked about, such as highly confidential data, are protected. When threat modeling is performed early, it brings a great advantage. Potential issues can be found early and solved, saving a lot of fixing costs and also just saving a lot of drama down the line. And there are various methods to perform threat modeling. Not all methods have the same purpose. Some focus on risk or privacy concerns, while some are more customer focused. We can combine these methods to understand potential threats better. It is essential to analyze which way aligns more with the project or business. So, some threat modeling methodologies might be a better fit for what your actual product is or your actual organization, and you want to choose the best one. And then we have Stride, Dread, and Pasta are among the most common threat modeling methodologies. Stride is the first one here. Stride stands for spoofing, tampering, reputation, which I can never say that without making it sound like reputation, information disclosure, denial of service, and elevation/escalation of privileges. Stride is a widely used threat model developed by Microsoft, which evaluates the system's design in a more detailed view. We can use Stride to identify threats, including the property violated by the threat and the definition. The system's data flow diagram is to be developed in this model, and each node is applied with the Stride model. So everywhere your data is going and touching, you're going to use Stride to do analysis on it. Identifying security threats is a manual process that tools are not supported and should be carried out during the risk. Hold on a minute. What incarnation? All right, so we got identifying security threats is a manual process that tools are not supported and should be carried out during the risk assessment. All right. Using data flow diagrams and integrating Stride, the system entities, attack surfaces, like known boundaries and attacker events become more identifiable. Then they just tell us what the acronym stands for again here. And Stride is built upon the CIA triad principle. So CIA is like core to information security. It stands for confidentiality, integrity, and availability of data. And security professionals that perform Stride are looking to answer what could go wrong with this system. Here are the components of the framework. All right, and that's just a visual again of the Stride acronym. And here the words are defined again, but we get a little bit more of a definition. Spoofing is an act of impersonation of a user by a malicious actor, which violates the authentication principle from the perspective of the CIA triad. And then tampering, the modification of information by an unauthorized user. Tampering violates the integrity principle of the CIA triad. Repudiation, oh, that's the best pronunciation I've had by far of it. So repudiation is not taking responsibility for events where the actions are not attributed to the attacker. It violates the principle of non-repudiability. For example, the attacker clears up all the logs that could lead to leaving traces. So as like most simple, I would just think of repudiation as as saying, I didn't do this, like not taking responsibility. And then you do things like clearing up logs, anything that could prove that you did it. You don't want your system to allow for repudiation. And then information disclosure is an act of violation of confidentiality of the CIA triad. A typical example would be a data breach, okay? And then denial of service. Denial of service occurs when an authorized user cannot access the service, assets, or system due to the exhaustion of network resources. And DOS is a violation of the availability principle of the CIA triad. And then elevation or escalation of privileges. Escalating privileges to gain unauthorized access is a classic example of the violation of the authorization principle of the CIA triad. All right, and that was already a lot, and that's just the first one. So just to summarize, for Stride, we had S is spoofing, T is tampering, R is repudiation, I is for information disclosure, which is like leaking data, D is for denial of service, and then E is for elevation or escalation of privilege. And that's one way you could do threat modeling. Next is DREAD. The abbreviation DREAD stands for 5 questions about each potential: damage potential, reproducibility, exploitability, affected users, and discoverability. DREAD is also a methodology created by Microsoft, just like Stride, which can be an add-on to the Stride model. I didn't know that. It's a model that ranks threats by assigning identified threats according to their severity and priority. In other words, it creates a rating system that is scored based on risk probability. Without STRIDE, the DREAD model can also be used in assessing, analyzing, and finding the risk probability by threat rating. Here are the components of the framework. So it's built to be used with STRIDE, sounds like, but you can also use it without STRIDE if you want to. The D is damage, and that refers to the possible damage a threat could cause to the existing infrastructure or assets. It is based on a scale of 0 to 10. A score of 0 means no harm, 5 means information disclosure, 8 means user data is compromised, 9 means internal or administrative data is compromised, and 10 means unavailability of the service. Okay. Reproducibility measures the complexity of the attack. So, how easily could an attacker replicate that threat? A score of 0 means the attack would be nearly impossible to copy. 5 means it would be a complex attack, but it would be possible. 7.5 means an authenticated user could do the attack. And a score of 10 means that the attacker could easily and quickly reproduce the attack without any authentication. Exploitability refers to the attacker's sophistication or how easy it would be to launch the attack. A score of 2.5 implies it would require an advanced skill set of networking and programming skills. 5 means the threat could be exploited with available tools. A score of 9 means we would just only need a simple web application proxy tool. And a score of 10 means that you could exploit through the web browser. The A is affected users, and affected users describes the number of users affected by a successful exploitation of a vulnerability. A score of 0 would mean that there would be no affected users. 2.5 shall mean for an individual user would be affected by this vulnerability. 6 would mean a small group of users. 9 would mean significant users like administrative users. And then 10 would imply that all your users are going to be affected if this vulnerability is exploited. 5 is discoverability, the process of discovering the vulnerable points in the system. For example, the threat would be easily found in the case of compromise. So how discoverable is the threat? A score of 0 would mean it would be very challenging to discover that vulnerability and exploit it. A score of 5 means that the threat could be discovered simply by analysis of HTTP requests. And 8 means the threat could be easily found because it's public facing in some way. And then lastly, a score of 10 would mean the threat is visible in the browser address bar. All right, so that was dread. And let's do a quick recap again. D was damage, what the damage would be of the threat. R is reproducibility, how easily an attacker could reproduce the attack. E was exploitability, which was like kind of, I think, the ability level needed to exploit the threat. A was affected users. How many users would this affect if the threat or the vulnerability were to be exploited? And then D, what was the D? Oh, discoverability. So that the second D is discoverability. How easy would it be to discover this threat vector? All right, so that's dread, and I kind of like dread better than stride so far. And then the other one is PASTA, and you just know somebody is so happy they got to name this PASTA. So PASTA is short for Process for Attack Simulation and Threat Analysis. It's a risk-centric threat modeling framework. PASTA's focus is to align technical requirements with business objectives. PASTA involves the threat modeling process from analyzing threats to finding ways to mitigate them, but on a more strategic level and from an attacker's perspective. It identifies the threat, enumerates them, and assigns them a score. This helps organizations find suitable countermeasures to be deployed to mitigate security threats. PASTA is divided into 7 stages, and I do like this nice graphic with the circles. And then under the graphic, they explain what each of these stages are. So number 1, define objectives. The first stage focuses on noting the structure and defining objectives. This makes the end goal a whole lot clearer and ensures that relevant assets are threat modeled by defining an asset scope. Then 2, define technical scope. This is where architectural diagrams are defined, both logical and physical infrastructure, helpful in mapping the attack surface and dependencies for the environment. All right. Decomposition and analysis. Each asset will have a defined trust boundary that encompasses all its components and data in this stage. For example, mapping threat vectors for a payment service and evaluating which components underlying the service could be leveraged for an attack. Components can be libraries, dependencies, modules, underlying services. I would say maybe like a third-party vendor. So that's number 3, is decomposing the application into the different services and then the services into the different components and how they could be exploited. Threat analysis, stage 4. This refers to the extracted information obtained from threat intelligence. And threat analysis is useful to identify which applications are vulnerable to specific attack vectors. For example, a customer or public-facing application can be susceptible to DDoS, distributed denial of service attacks, and unauthorized data. 5 is vulnerabilities and weaknesses analysis. It analyzes the vulnerabilities of web application security controls. It identifies security flaws in the application and then enumerates vulnerabilities. It is highly recommended to add mitigation to the identified threat in this stage. For example, when describing a past incident involving an exploit of a mail server, lessons learned, or how we could mitigate that vulnerability that caused the incident in the future. So maybe the lesson learned was lack of thorough testing before the implementation, and the mitigation will be hardening the server going forward. 6 is enumerating and modeling attacks and exploits. In this stage, we map out the potential threat landscape and the entire attack surface of our web application. We then map all the potential attack vectors to the different nodes, the different parts of the application, identifying different exploits and attack paths that might be possible. This stage simulates all the enumerated information extracted from all the previous steps. This helps security professionals determine the extent and probability of successfully launching the identified vulnerabilities. 7 is risk impact analysis. Based on the collective data from the previous stages, all of the scoped assets that have been affected are analyzed, and finally, based upon the risk analysis, recommended steps to mitigate the risks and eliminate all of the residual risks are documented. Whew, that is like a dense section. All right, so that was the 3 different threat modeling frameworks we learned about, right? So that was STRIDE, DREAD, and then the last one was PASTA. Here are our questions for task 5. What threat modeling methodology assigns a rating system based on the risk probability? So that was DREAD, right? I am almost certain. DREAD almost has like kind of a rubric that helps you rank from the 0 to 10. Yep. What threat modeling methodology is built upon the CIA triad? So that was STRIDE. And then lastly, what threat modeling methodology helps align technical requirements with business objectives? So that was PASTA, the creatively named PASTA threat modeling framework. And that is task 5. So let's move on to task 6. Task 6 is called secure coding. And this is the kind of DevSecOps stuff I really like and really nerd out about. So secure code review and analysis. According to research conducted by Verizon in 2020 on data breaches, 43% of breaches were attacks on web applications, while some other security breaches resulted from some vulnerabilities in web applications. Wait, what? 43% of breaches were attacks on web applications, while some other security breaches resulted from some vulnerabilities in web applications. So the breaches maybe weren't on the web applications themselves, but resulted from something vulnerable about the web application. That's going to be my headcanon for that sentence. And then implementing a secure code review in the phases of an SDLC, especially during the implementation phase, will increase the resilience and security of the product without bearing any additional cost for future patches. Secure code review is defined as a measure where the code itself is verified and validated to ensure vulnerabilities that are found in the code are mitigated and removed to avoid vulnerabilities and flaws. Basically, we find the vulnerabilities in the code before the code ever makes it to the production application. Having the developers be aware and proactive in reviewing the code during development can result in faster mitigation responses and fewer unattended threats. Reviewing code is a crucial step in the SDLC for developers. It prevents any setbacks on the release and issues exposed to the users. As shown in previous SSDLC tasks, the cost of the project itself and the effort put in is proportional and cheaper in the long run than the cost of applying code reviews and analysis. By implementing this approach, I think meaning secure code reviews, the organization will also be compliant with the standards set by different government bodies and certifications. Code review can be done manually or automated, or both. A manual code review is where an expert analyzes and checks the source code by going line by line to identify vulnerabilities. Therefore, a high-quality manual code review requires the expert to communicate with the software developers to get hold of the purpose and functionalities of the application. The analysis output will then be reported to the developers if there is a need for bug fixing. So that's maybe like it. Ideally, a code review is done by an expert. That might not always be the case. And then code analysis. Static analysis examines the source code without executing the program. In contrast, dynamic analysis looks at the source code while the program is running. Static analysis detects bugs at the implementation level, and dynamic analysis detects errors during the program runtime. Automated static application security testing, SAST, automatically analyzes and checks the source code. And I believe in this learning path coming up, there are rooms about SAST and DAST both, so static and dynamic application security testing. So I think we're just getting the description now, and then we're going to actually do it hands-on in future rooms. So SAST means static application security testing, a white box testing method that directly analyzes the source code. Many people tend to develop an application that could automate or execute processes quickly and improve performance and user experience, thereby forgetting the negative impact an application that lacks security could cause. So you don't want speed to come at the cost of security. And why is it static? It's static because the test is done before the application is live and running. SAST, so the code's just like laying there, it's not running, and you're just reading it. And SAST can even help detect vulnerabilities in your application before the code is merged or integrated into the software if it's added as part of the SDLC development phase. How does SAST work? SAST uses a testing methodology of analyzing a source code to detect any traces of vulnerabilities that could provide a backdoor for an attacker. SAST usually analyzes and scans an application before the code is compiled. The process of SAST is also known as white box testing. They just said that. Once a vulnerability is detected, the following line of action is to check the code and patch the code before the code is compiled and deployed to live. White box testing is an approach or method that testers use to test software's inner structure and see how it integrates with external systems. And another example of SAST I wonder if we're going to talk about, especially because they have the infrastructure as code room coming up later on, is that when you are deploying your infrastructure using infrastructure as code, SAST is really helpful because it can help you catch an insecure configuration before it's ever been deployed anywhere, because it can look at your infrastructure as code, the way you're configuring that infrastructure, and it can tell you, hey, like you have an insecure configuration here. And then bonus SCA. To summarize, SAST is used to scan source code for security vulnerabilities. Another type of testing goes hand in hand with SAST, and that's software composition analysis, or SCA. SCA is used to scan dependencies for security vulnerabilities, helping development teams track and analyze any open source component brought into a project. So, and if you don't do like a lot of coding, most of the time when you have an actual like full scale software application that you are developing, part of what you are doing is you're using libraries in your code, and libraries is just essentially like more code that somebody else has written, open source libraries. So it's not code you've written, you're just importing it and running it as part of your application. And SCA, software composition analysis, looks at all the different libraries and modules you're importing into your code and helps you see, is there anything insecure in those different building blocks that are becoming part of your code. And nowadays, one of the biggest challenges developer teams have is ensuring their code base is secure as applications are assembled from different building blocks. Exactly. And then DAST. DAST is dynamic application security testing, and this is black box testing that finds vulnerabilities at runtime. DAST is a tool to scan any web application to find security vulnerabilities. This tool is used to detect vulnerabilities inside a web application that has been deployed to production. And DAST doesn't only just have to be done on web applications. DAST tools will always send alerts to the security team assigned for immediate remediation. How does DAST work? DAST works by simulating automated attacks on an application, mimicking a malicious attacker. The goal is to find unexpected outcomes or results that the attackers could use to compromise any application. Since DAST tools don't have internal information about the application or the source code, they just attack just like an external hacker would. So you're just automating what you think an external hacker would be doing, and the hacker doesn't really usually know like your source code, so you're just going through the motions that the hacker would, with the same limited knowledge and information about the application. That's what makes it black box, because you can't see the inner workings. DAST is a tool that can be integrated very early into the software development lifecycle. Its focus is to help organizations reduce and protect against the risk that application vulnerabilities could cause. It's different from SAST because DAST uses black box testing methodology. It conducts its vulnerability assessment outside, as it does not have access to application source code. DAST is typically used during the testing phase of SDLC. And then next is IaaS, which stands for Interactive Application Security Testing, that analyzes code for security vulnerabilities while the app is running. It is usually deployed side by side with the main application on the application server. IaaS is an application security tool designed for web and mobile applications to detect and report issues even while running. Before someone can fully comprehend IaaS understanding, the person must first know what SAST and DAST mean, which now we do because we read about them, and hopefully we'll understand it even better when we actually do it. IaaS was developed to stop all the limitations in both SAST and DAST. It uses the gray box testing methodology. How does IaaS work? IaaS testing occurs in real time, just like DAST. While the application is running in a staging environment, you don't want to be doing your IaaS testing in prod. IaaS can identify the line of code causing security issues and quickly inform the developer for immediate remediation. IaaS checks the source code similar to SAST, but at the post-build stage, unlike SAST, which occurs during development. IaaS agents are typically deployed on the application servers. When the DAST scanner performs its work by reporting a vulnerability, the deployed IaaS agent will now return a line number of the issue from the source code. So that's obviously really great, right? Because that'll make it so much easier to remediate. You can go right to the problematic line of code and you know what to fix. You can deploy IaaS agents on an application server. During functional testing performed by a QA tester, the agent studies every pattern that a data transfer inside the application follows, regardless of whether it's dangerous. For example, if data is coming from a user and the user wants to perform an SQL injection on the application by appending an SQL query to a request, that request would be flagged by the agent as dangerous, but the agent is just looking at every single request. Oh, and then we have a bonus here. So RASP stands for Runtime Application Self-Protection. RASP is a runtime application integrated into an application to analyze inward and outward traffic and end-user behavioral patterns to prevent security attacks. This tool is different from other tools as RASP is used after the product is released, making it a more security-focused tool when compared to others that are more known for testing. So this is in your production environment running as part of your application. How does RASP work? RASP is deployed to a web or application server next to the main application while running to monitor and analyze inward and outward traffic behavior. Immediately, once an issue is found, RASP will send alerts to the security team and immediately block access to the individual making a request. So this part's really important. So a good example would be like a password dictionary attack where one individual IP address is maybe just like throwing all these different passwords at your login mechanism, and RASP could figure out that's going on, alert on it, and then block the IP address of the individual making all those requests to protect you from the attack. When you deploy RASP, it will secure the whole application against different attacks. It does not just wait or try to rely only on specific signatures of some known vulnerabilities. RASP is a complete solution that observes every detail of different attacks on your application and knows your application behavior. So it learns what's normal for your application so that it can then detect when something weird is going on. Choosing tools, SAST, DAST, and IaaS are great tools that complement each other. A key strength of DAST is that it identifies runtime issues, weaknesses that aren't discoverable when the application isn't running, things you wouldn't see just from looking at the static code. SAST is excellent at identifying vulnerabilities while code is being written, so you never even have to commit the bad code in the first place. Additionally, DAST looks at how an application responds to an attack, providing helpful insight into how likely it would be for that vulnerability to be manipulated. AST, I think maybe that means IaaS, enables DevSecOps and supports continuous testing, monitoring, assessment, and validation in real time. IaaS helps prioritize and alert on vital, critical risks as defined by business goals and application security needs. The security experts always support using 2 or more of these tools to ensure better coverage, which will lower the risk vulnerabilities in production. So most of the time they're designed to be used together. Ensure you fit these tools to the way engineers push code and interact with your pipeline, meaning like your CI/CD pipeline that you use to deploy code. Watch out for integrations and focus on providing support and education versus being a blocker. So being a blocker in this instance means you don't want to slow down what the developers are doing trying to get their features released or whatever. For example, if choosing SAST, you can integrate it when engineers push code and then they can get feedback on the PR before merging. So before they add their code to the code base, SAST is already telling them, hey, fix this and this now, and then it's not a problem later on. Timeline of application security automation. So check the diagram below to see where you can fit security testing tools. All right, so timeline of application security testing. So here we have development, we have integration, acceptance stage, pre-prod stage, and production. And this is the journey that new code would follow. So from here, where developers are working on the code, writing the code, to now the code is running as part of your production application. So in the development phase, we can be using the static analysis, and then SCA, like looking at your libraries and dependencies. Integration testing, the integration, which would be where you're like proposing, I'm going to add this new code to the code base. We can be doing SCA. The acceptance stage, we can be doing static analysis and dynamic analysis, where we're deciding, yeah, we're going to accept this new code and add it in. And then the pre-prod stage, so usually, hopefully, that'd be like some sort of testing or staging environment after you've added the code, but now you're still going to deploy it to staging first. So there we can be doing all three. And there we can be doing all three. So we can be doing the static analysis, we can be doing the dynamic analysis, and we can be doing the interactive analysis. And lastly, in production, running alongside our production, we will be having the RASP, which is like the runtime protection that's going to alert on any weird behavior in our production application. And we can do things like block suspicious IP addresses and things like that. So that was the standard timeline when choosing when to implement security testing tooling. As described earlier, SAST is a static approach. There's no need for the running application, so that's why we can start doing it right here. Therefore, SAST can be implemented in the earliest development stages. SCA typically works best for identifying open source components like packages and dependencies. It is also beneficial for identifying open source licenses being used. That's true, especially from a legal risk perspective. Because of this, you can implement governance and control by enforcing security and license policies across different stages of the SDLC. On the other hand, DAST relies on the execution of the application. So that's why here where we start doing like testing and staging, that's when we can start doing DAST, because we actually need to run the application. So integrating it in the pipeline is not as straightforward as SAST. DAST is typically implemented after the acceptance stage of the code and pre-production stage, and this is where the application starts running in testing environments such as staging. And similar to IAST, DAST and IAST reside on the far right of the pipeline because the execution of your application is required for DAST tools to do their work. This can become quite time-consuming, significantly if your application has grown over time, because you're typically integrating the new code into the existing code base and then running the entire application in your staging environment. RASP helps to uncover third-party packages and associated vulnerabilities at runtime, more effectively enabling developers to prioritize the remediation and mitigation of the most pressing vulnerabilities. This is usually enabled in production, as security vulnerabilities are evaluated during the runtime of the application. And here are our questions for task 6. Is it recommended to use SAST analysis at the beginning of the SDLC? Yes, you want to do it right from the beginning. All right, and what type of code analysis uses the black box method? So remember, that's DAST, where there's no knowledge of the source code. It's just interacting with the running application the same way like an external attacker would. So that's DAST. And then which type of code analysis uses the white box method? So that is SAST, because it's actually looking at the source code. All right, and that is task 6. That was like another hefty one, but that was a little bit more up my alley, so I enjoyed that. And then task 7 is going to focus on security assessments. All right, security assessments. And I'm starting to think this might win the world record for longest room video yet. A security assessment plays a primary role in achieving security in SDLC and should be implemented in all phases where possible. Security testing assesses a system, software, or web application for vulnerabilities and other attack vectors. Because they test from a holistic point of view of the application, they are usually carried out at the end of the SDLC in the operations and maintenance phase. Once the version has included all the working components and updates, there are 2 types of assessments: penetration testing and vulnerability assessment. Usually, a company employs and authorizes external security testers to attempt to break into a company's network and systems legally. Vulnerability assessments focus on finding vulnerabilities, but do not validate them or simulate the findings to prove they are exploitable in reality. So vulnerability assessments identifies here's where it's vulnerable, here's where it could be exploited, but it doesn't actually exploit it. And then typically, automated tools run against an organization's network and systems. Some examples of these tools would be OpenVOS, Nessus, and ISS Scanner. These scanners probe ports and services on systems across various systems. Hold on, what? These scanners probe ports and services on systems and across various systems and IP addresses. Other activities include checking service versions against a database of vulnerabilities affecting said version. The result is a report with a list of vulnerabilities usually found with an automated threat level security classification, e.g. high, medium, low, or an assigned CVSS score. And then penetration testing. So penetration testing includes vulnerability testing, but goes more in depth and it is extended by the testing and validating of vulnerabilities. Penetration testing actually exploits the vulnerability, which helps quantify the risk, and then you are attempting to penetrate the system. For example, you're trying to escalate privileges after a vulnerability is found. Some vulnerabilities can be lower risk, but then can be used to leverage to cause more damage. The tester can provide a thorough report with suggested countermeasures to mitigate the vulnerabilities that were found and exploited. This makes it easier to understand the threats you're facing by demonstrating the actual risk. For example, your penetration tester could demonstrate recovering an employee password by exploiting a vulnerability that they found. And here are some pros and cons. So pros and cons of the vulnerability assessment. The pros are it's faster, it's suitable for quickly identifying potential vulnerabilities. It can be part of a penetration test. I don't know if that's really like a pro, that just describes it, but it can be part of a penetration test, and it's cheaper than penetration testing, so that's a pro. And cons, it can produce a large number of reports. That's true. It can definitely give you a lot of information that you then have to parse through and prioritize. The quality of your vulnerability assessment depends a lot on the tool that you use. Real life scenarios for vulnerabilities are not considered. So a vulnerability could be behind a proxy, or it could only be exploitable with social engineering and credentials, and those are the types of details that might not really come out in a vulnerability assessment. And the low risk vulnerability might be used as part of a more powerful attack. So again, a vulnerability assessment might show that a vulnerability is a lower risk vulnerability, but might not get to the full context in which that vulnerability could be exploited the way that a penetration test would, and would demonstrate the attack chain. And then penetration testing. So the pros, the tester shows organizations exactly what an attacker could actually do, how the attacker could leverage the different vulnerabilities. And then I screwed up because that's the exact next thing. So how any vulnerabilities could be used against it by attackers. The real penetration testing reveals the real risk for a company. And penetration testing can be shown to the customer. That's kind of like a weird pro because vulnerability analysis can also be shown to the customer. But okay, we'll just roll with it. And then the cons of penetration testing is a lot more expensive, and it requires a lot more extensive planning and time to carry out the penetration test. All right. And here are our questions for task 7. Which form of assessment is more budget friendly and takes less time? So vulnerability assessment. Let's see if I got that. Yep. And then which type of assessment identifies vulnerabilities and then attempts to exploit them? So that is penetration testing. All right. And then when do you typically carry out vulnerability assessments or pen tests? Oh, good question. I'm not sure that one. All right, let's see. It says all phases of the SDLC when possible. No, and let's see. So we're looking for, when do you typically carry out? At the end of the here we go, operations and maintenance phase. Because they test from a holistic point of view of the application, they are usually carried out at the end of the SDLC in the operations and maintenance phase. All right. So that makes sense, right? Because like the vulnerability scanning, you can do that earlier and earlier now, which is the point of DevSecOps. But pen testing especially, you usually do when your application is in production, when your application is running for real in its real environment. But all right, so that still doesn't really suit here. Let's see. Let's try that. Oh, okay, that was right. So instead of and, it was a plus sign. All right, awesome. So operations and maintenance phase, and then we'll move right on to task 8. Task 8 is about different SSDLC methodologies. You can follow different methodologies to integrate security in the SDLC best. Before we dive into each method, regardless of the chosen development methodology, Agile, DevOps, Extreme Waterfall, etc., so we learned about those in the intro to DevOps room, there is a need to build with security in mind and introduce testing focused on security. So that's a commonality no matter what your software development methodology is. There are several methodologies for SSDLC, Secure Software Development Lifecycle. Some examples of widely used methodologies are Microsoft's Security Development Lifecycle, SDL, OWASP's Secure Software Development Lifecycle Project, and Software Security Touchpoints. Microsoft's SDL, so the SDL principles are secure by design. Security is a built-in quality attribute affecting the whole software lifecycle. Security by default, software systems are constructed to minimize potential harm caused by attackers. For example, software is deployed with the very least necessary privilege for it to do what it needs to do. And if you want to know more about least privilege, you can go watch my video of my AWS Quest for Least Privilege room I did not too long ago. And then secure in deployment. Software deployment is accompanied by tools and guidance supporting users and administrators. Communications. Software developers are prepared for occurring threats by communicating openly and timely with users and administrators. That's the 4 principles of SDL, Security Development Lifecycle. SDL is a collection of mandatory security activities grouped by the traditional software development lifecycle phases. Data is collected to assess training effectiveness. In-process metrics are used to confirm process compliance. Post-release metrics are used to guide future changes. SDL places heavy emphasis on understanding the cause and effect of security vulnerabilities. A development team must complete the mandatory security activities to comply with the Microsoft SDL process. You can implement SDL by following these practices. So here are some of the SDL practices. Maybe all of them. Provide training, define security requirements, define metrics and compliance reporting, performing threat modeling, establish design requirements, define and use cryptography standards, managing the security risk of using third-party components, perform security testing, so that's SAS, DAS, and IAS that we learned about, performing security assessments, such as the vulnerability assessment and pen testing that we just talked about, establish a standard incident response process. Preparing an incident response plan is crucial for helping to address new threats that can emerge over time. So you don't want to be like figuring it out as you go, as the threat is happening, as the attack is happening. You want to already have an incident response process in place. So that was Microsoft SDL. And then the next security assessment we're going to talk about is OWASP S-SDLC. So there are it's like a tongue twister. Oh my God, it's like a tongue twister. So there are SSDLC principles from OWASP. SDL is a collection of mandatory security activities grouped by the traditional software development lifecycle phases. Data is collected to assess the effectiveness of your training. In-process metrics are used to confirm the process compliance. Post-release metrics are used to guide further changes. SDL places heavy emphasis on understanding the cause and effect of security vulnerabilities. A development team must complete the 16 mandatory security activities to comply with the Microsoft SDL process. OWASP SSDLC aims to build security quality gates to support quality and secure software made throughout the pipeline. This is done by following an agile security approach. So SDL kind of seems like fits more in with waterfall, they're saying, and then OWASP SSDLC is more based on agile, where sprints are dedicated to security. Examples of sprints could include code reviews, authentication, authorization, input validation, and assessing technical risks like code injections. And OWASP, if you're not familiar, does the top 10 web application vulnerabilities. The gates compromise sprints focused on similar building blocks like those seen in Microsoft SDL. OWASP SSDLC agile approach is heavily influenced and based on the maturity model approach, in particular OWASP SAM. SAM is the software assurance maturity model, and it's an open framework to help organizations formulate and implement a software security strategy tailored to the organization's specific risks. It helps to evaluate an organization's existing software security practices, build on a software security assurance program, demonstrate improvements to that program, and define and measure security activities for an organization. SAM helps explain objectives, actions, results, success metrics, costs, etc. An example would be a security scorecard for gap analysis, for instance, in a particular area like your endpoint protection, aims to answer how well are we doing and where do we want to get to, and you can go read about it on the OWASP website. And here's an example. So these gates are like you would need to unlock these to move on to the next phase. So you would do high-level security risk analysis for your project definition, and then the gate before you move on would be like you would agree to the concept and priority. Then the next part would be you're going to select your security controls as part of the preliminary design, and the gate to move on would be you're going to agree to the project definition with those security controls identified. Then you're going to do a security design review and a source code review for security. And then the gate here to move on would be like everyone's going to agree to the preliminary design. And then gate 4 would be, all right, we're going to approve the build for deployment once we've done like the pen testing and the third-party assessment. And lastly, we've got one more little baby security assessment model. Another critical security model is building security and maturity model, and that's BSIM. I don't know if that's how you say it. I've only ever read this. I've never said it, but I'm going to call it BSIM. Is a study of a real-world software security initiatives and reflects on the current state of software security. BSIM can be described as a measuring stick to understand your security posture by providing a comparison of other companies' security states. So it helps you do like benchmarking, helps you keep current with what's going on. In other words, it does not tell you what you should do, but rather what you're doing wrong. Nice. And there are hundreds of organizations involved, and you can go read more about it there. All right, but BSIM helps you do benchmarking and reflects the current state of software security would be the things I would pull out of that. So what methodology follows a set of mandatory procedures embedded in the SDLC? So that was the Microsoft SDL. All right. What maturity model helps you measure tailored risks facing your organization? So that was OWASP security something maturity model. Yep. And then what maturity model acts as a measuring stick to determine your security posture? And that was BSIM. What does BSIM stand for again? Building security and maturity model. All right, and that was task 8, and I think that was the last of our long marathon reading sessions. So we can move on to task 9, which I believe is going to be like the hands-on, because I see this has a static website here. So let's do task 9, and then we will be done with this room. Task 9, secure space lifecycle. Let's see what's going on here. And we have a static site to bring up. Okay, cool. Very nice. Introduction. Ensure you are able to travel through the SDLC in a secure manner by selecting which secure processes you can implement at each stage. Safe travels. And to start, we select view site, which we already did, and we're going to find a flag here. All right. We need you to help to get S2D2 out into space. The only way we can do this is by flying the rocket through the correct security stage portals of the software development lifecycle. Use the left and right cursor keys to move your spaceship. Oh, this can be fun. Okay. Which security procedure would you choose for the planning and requirements stage? Oh, and we have to, oh my gosh, you have to go so fast. Risk management. Okay. What security procedure would you choose for the design and prototyping stage? All right, so that's threat modeling. What security procedure would you first choose for the software testing stage? All right. Threat modeling, What security procedure would you choose for the second part of the software testing stage? What security procedure would you choose for the third part of the software testing stage? Risk assessment. Oh, I think that was supposed to be code review. Okay, shoot. Let me try again. All right. What security procedure would you choose for the planning and requirements stage? All right, so that was risk management. I try not to say the F word this time. What security procedure would you choose for the design and prototyping stage? Threat modeling. All right. What security procedure should you choose for the first? So that was SAST, right? Yes. All right. What security procedure would you choose for the second part of the software testing stage? This is so fun. That was DAS, dynamic. All right. What security? So this was code review, I'm pretty sure. Let's see. It's definitely not risk assessment. All right. What security? So first choose. So maybe this is going to be vulnerability scanning. Let's see. Cry, scream. Ah! Oh my God. What was it? I didn't even have enough time to read what the options were. All right, let's try this again. Third time lucky. Let's see. Risk management. Threat modeling. What security procedures should first choose for the software testing stage? SAST. The suspense. DAST. Code review. All right, was this where I messed up before? Secure configs. Second part of the developing operations and maintenance stage. No. Security assessment. All right, we did it. So we got the flag. That was fun. Some of them was like harder than it looked because you didn't have enough time to read all the options. And I'm fat. All right, so our flag is do a barrel roll. And let's paste that. And we have officially finished the SSDLC, Secure Software Development Lifecycle room. And the next room is Intro to Pipeline Automation. So I think now we're going to be really getting to the more hands-on fun stuff and maybe a little bit less of the reading. Thank you so much for watching this walkthrough. I think the next rooms in the learning path are going to be a lot of fun. And maybe I will see you in another room walkthrough soon.